Assalamualaikum, my name is Siti Nazira Akina. I will explaining about application and cases of valve in series and parallel. For number one, valve in series and how it works. Valve in series are connected one after another in the same line. Flow must pass through each valve in order. For industrial application, redundancy in isolation are often used in critical system. For example, in nuclear chemical plants, where a second isolation valve is placed for fail-safe shutdowns. For stage pressure drops, it used when a single valve can't handle the full pressure drop, like in high pressure steam systems. For the flow regulation and safety, a control valve followed by a safety shut-off valve. For example, system in oil, gas and pipelines, isolation valve in series to ensure zero leakage during maintenance. In steam lines, pressure reducing valve plus back pressure valve. In pharmaceutical clean room process, series valve ensures sterile barriers between zones. This is an application and use cases for valve in parallel. How it works is valve in parallel allow flow to go through one or more paths and often used to increase reliability, handle maintenance or adjust capacity. For industrial applications, redundancy or reliability, if one valve fails, flow can be rerouted and for load sharing or capacity control. Open multiple paths to handle more flow. And for bypass lines, common in maintenance or startup procedure. This is the example system in parallel series. Water treatment plants, parallel filter units with valve to isolate any unit. For pump system, suction or discharge valve in parallel to switch between pumps. And for cooling system, parallel heat exchangers or chillers, each with valve isolation. And the last one is chemical batching system. It is routing ingredients through parallel paths.
Assalamualaikum, my name is Fatiha. Now let's talk about valve in series. In this setup, valve arrange one after another in the pipeline, so the fluid must pass through each valve sequentially. One of the main reasons for using this arrangement is redundancy. If the first valve fails or leaks, the second valve can act as a backup to ensure the flow is completely stopped. We also use this setup to achieve enhanced isolation. A common example is the double block and bleed system, where two block valves are installed with a bleed valve in between. This allows us to safely release any trapped fluids and confirm full shut-off before maintenance. In some cases, we use multiple valves in series to gradually reduce pressure in stages, protecting downstream equipment from sudden pressure drops. Although less common, this arrangement can also be used for sequential fluid operation, where each valve performs a specific task along the flow path. And overall, valve in series help improve the reliability of the system by adding backup sealing and better flow control. And now, let's move on to valve in parallel. In parallel arrangement, valves are installed side by side. The flow splits and the fluid can pass through multiple valves at the same time. This setup increases the total flow capacity of the system. The combined flow from all parallel valves is higher than using a single valve. It also allows for more precise flow control instead of relying on one large valve. We can fine-tune several smaller ones to get the exact flow rate we need. Another advantage is operational flexibility. If one valve needs maintenance, the other valve can still operate. This means we don't have to shut down the entire system. Okay. This also gives us partial redundancy because even if one valve is offline, the rest can still handle part of the flow. Okay. Lastly, parallel valve help with load sharing. The flow and pressure drop are more evenly distributed, which improve system efficiency and reduce wear on individual components. I will pass to the next presenter.
Assalamualaikum. Hi, my name is Nomala binti Malik. So I will talk about advantage and disadvantage in series valve system. The first one is precise control. The use of multiple valves in series system can control flow and pressure more precisely. This is especially important in systems that require tight control, such as chemical processing or gas system. And number 2 is additional safety. Like if one valve fails, the other valve in the series can act as an additional layer of safety. This reduces the risk of failure in the entire system. And number 3 is step pressure reduction. In system with high pressure, a series configuration can be used to reduce pressure in stage to prevent damage to components or pipes. And lastly, for the advantage, series valve system is suitable for complex system. Like this configuration is very useful in systems that require very specific pressure or flow control. And the disadvantage in series valve system is the first one is high pressure drop. So the resistance to flow will increase at each valve in series. And number 2 is limited flow rates. Because flow must pass through all valves in one pass, the overall flow rate is limited compared to parallel configuration. And number 3 is system shutdown and failure. It's because if one valve in series fails or malfunctions, the entire system may stop functioning because the flow is completely blocked. And lastly for the disadvantage in series valve system is increase maintenance effort, because the assessing and maintaining valve in a series configuration can be challenging, especially in confined space or system with multiple valves in a row. Okay, next, this is advantage and disadvantage in parallel valve system. For the first one is high redundancy. When if one valve fails and needs to be maintained, other parts can still be used without stopping the entire system, ensuring that the flow system continues to run smoothly. And number 2 is operational flexibility. Because this parallel valve system can control the flow by operating or closing specific valves without affecting the entire system. For example, you can choose which path to use. And number 3 is high flow capacity. With multiple paths, the amount of fluid that can flow through the system will increase. This is very useful in systems that require large flows, such as cooling system. And then lastly, for the advantage in parallel valve system is reduced pressure loss. The flow is distributed over multiple paths, so the resistance in each path is reduced. So result in lower pressure will lose. And so the disadvantage in parallel valve system, number 1 is complex design, because this system is more complicated to design because it required more planning and installation, because there are many connection and roads. And number 2 is high cost. This parallel valve system requires high cost because more valves or more part and components required to be installed. And number 3 is space requirement. This parallel valve system, when installed valve on multiple roads, can cause this system to require more space. And lastly, for this disadvantage in parallel valve system, is increased maintenance effort. The maintenance workload is higher as every valve and associated piping requires frequent inspection and servicing. So that's all from me.
For mechanical issue involved and recent technology in series, for mechanical issue are increased pressure drop, each valve add assistant. Second one, cavitation risk, high pressure drop across valve can cause vapor bubble. For recent technology are smart valve with IoT sensor, monitor pressure, temperature and wear in real time to predict failure. Anti-cavitation trim design, modern valve use special trim to reduce bubble formation. DBB valve, 2 valve in series with bleed port for testing integrity. In parallel, the mechanical issue are flow imbalance, uneven pressure distribution cause valve to dominate flow. Water hemorrhage, sudden valve closure in one line can cause pressure surge. For recent technology are automatic flow control valve, IR driven valve, adjust opening to balance flow. Self-sealing valve use elastomer or magnetic seal. Last one of soft close actuator prevent water hammer by shutting valve.